Hi everyone, I'm Peter. Today I'm going to explain the question 206, reverse linked list. In this question, we are given a head of a single linked list, and we need to reverse the list and also return the reversed list. And for example, in this example 1, we have 1, 2, 3, 4, 5, and we need to reverse it. And also, we need to return this new head. So which means the output will be 5, 4, 3, 2, 1. Okay, and I'm going to explain the solution both in iterative way and the recursive way. Okay, I'm going to explain the iterative solution firstly. In the iterative solution, we need pointers to help us. First of all, we need a previous pointer which points to null in the beginning. And also we need a current pointer which points to head node in the beginning. And then we need to modify the next pointer of the current node to point to previous. Okay, so for example, in a loop we need to change this next pointer to point to previous pointer, and we need to shift the pointers, including the previous pointer and the current pointer. So previous pointer will go here, and the current pointer will go here. But actually, we couldn't do this way. We couldn't directly change the current pointer here, because we don't have any pointers to store this node, right? Okay, so actually we need another pointer which calls next pointer, okay, to store the next pointer of the current node firstly. Okay, so we repeat previous action. We change the next pointer of the current node to point to previous, right? And change previous pointer here, and current pointer to next pointer, right? So it becomes this situation. And in the next loop, we need to store the next pointer firstly. So next pointer will be the next pointer of the current node, right? So next pointer will be here, and then we need to, as the same way, we need to change the next pointer of the current node to point to previous pointer, right? And as the same, we need to change the previous pointer here and change the current pointer here, right? And then the next loop, the same way, we need to change the next pointer to the next pointer to of the current node, right? So it will be the next pointer will be null, right? Here is null. And then the next pointer of the current node will change to point to previous pointer, right? So it will be here. And also change the position of previous pointer here and current pointer here, right? And once the current pointer becomes null, we can leave the loop. And what will we return? We will return the new head, which is previous pointer. Once we return this previous pointer, we return the whole new linked list. Okay, let's code it. Like I said previously, we need pointers to help us, right? We need a previous pointer. It points to none in the beginning, and we need a current pointer which points to head in the beginning, and we need a while loop. The condition is while the current pointer is none. And in the loop, we need a next pointer, which we need a next pointer to store the next node of the current node, right? So next pointer will be current dot next, and then we need to modify the next pointer of the current node, so it will be current dot next will be previous, will change to point to previous, and then we need to shift our previous pointer and the current pointer, right? Previous pointer will be the position of the current pointer, and the current pointer will be the position of next. Okay, so we will continually do this loop. Once the current node is null, okay, we will leave this loop. What do we need to return? We need to return the new head, which is previous pointer. Okay, so the solution is like this. Let us submit. Okay, no problem. Okay, let me explain the time complexity and the space complexity. The time complexity will be big O of n, because actually we need to traverse the whole linked list once. Okay, so and the space complexity will be big O of 1, because we need these pointers, previous pointer, current pointer, next pointers. They are fixed no matter how much the input are, right? So the space complexity is fixed, is constant. Okay, so let's explain the recursive solution. Okay, so we know in recursive solution we need to break down the task into subtasks. So instead of directly reverse this whole linked list, we could just break down into subtasks. So we could instead reverse this sublinked list. So it's a recursive reverse function. Okay, and we need to pass this head.next, this one. Okay, this sublinked linked list to this recursive function, and what will it return? It will return to us the reverse version of this linked list, right? So which means it will become the reverse version, right? So it will become this one. Okay, so but after that we could see there are two pointers we need to modify, right? This one and this one. Okay, it needs to be modified. So we could use head.next. Head.next is this one, and its next pointer need to change to point to head, right? So after we do it in this way, we could modify this one to point to head. Okay, and we know this head node is the last node, right? After reversing, so which means we could do head dot next equal to point to null, right? So after we do in this way, we could remove this pointer, this link to point to null. and after that we need to return this new head, right? Okay. So we know in recursive solution we also need to think about the base case, right? So what's the base case condition? The base case condition is if head is null or head dot next is null, and if this condition, we just return head. Okay, so which means if the head is null or there's only one node in this linked list, we just return head. Okay, so we could use this base case to explain this case. In this case, so in the recursive function, firstly we will pass the head.next, right? This one, right? And actually, in next step, we could also pass this node into the recursive function. So, and this one is base case. So it will return just this one, this node, right? So we will pop out and also do these steps, which means it will modify the pointers, right? So this one also, and just pop out and pop out again, and doing the same thing I previously mentioned, right? Just this one and this one, and we just return this new head. Okay, so let's coding. We know in this recursive solution, we need base cases, right? So which means if like I mentioned before, if head is none or there's only one node in this linked list, so or head dot next is none, we could just return head. Okay, and also we have new head. We need to call this recursive function. And the parameter will be head dot next. Okay, so after we pass this head dot next, this recursive function will return the reversed version of this linked list, right? And after doing that, there are 2 pointers we need to modify. The first one is head dot next need to point to current head. Okay, and also we also know the current head is the last node in the reversed version of the linked list, right? So head dot next need to point to none. Okay, and finally we could just need to return this new head. Okay, so above is the recursive solution. Let's submit. Okay, no problem. Okay, so let's explain the complexity analysis of this recursive solution. Firstly, the time complexity will be big O of n, because we need to traverse this whole linked list once. Okay, and about the space complexity, it will also be big O of n. because in the recursive solution we need extra space. It will come from the code stack due to recursions, and the recursion could go up to n levels deep, so which means the space complexity will be big O of n. Okay, that's all. Thank you for watching.